Right, question 6 is about period 3 elements and their oxides. So first question, write an equation for the reaction of phosphorus with an excess of oxygen. So we've got plenty of oxygen. So we need to remember that phosphorus is a molecule which is P4. It's going to react with oxygen and it forms an oxide that's P4O10. So therefore I need 5 O2s. I don't need state symbols for this. I'm just going to get 1 mark. It doesn't say that I need state symbols in the question and it's only 1 mark. Next question, describe a test you could carry out in a test tube to distinguish between sodium oxide and the product of the reaction in question 6.1. So that's phosphorus oxide. So that one there. So basically this is testing me on whether or not I know that the metal oxides across period 3 are basic and the non-metal oxides are acidic. So what I would do is I would get some water. I'd say react with water, react both oxides with water. I would measure some way of measuring the pH of each solution formed. So I could use UI paper or I could use a pH meter. And I would say that sodium oxide will have a high pH, going to be basic. And I can say phosphorus oxide will have a low pH, it's going to be acidic. And essentially I get 1 mark for the first bit, react with water, 1 mark for saying I'm going to measure the pH, and then 1 mark for saying how I'm going to tell the difference between the two oxides that I've got. Okay, next question, state the type of crystal structure shown in silicon dioxide and sulfur trioxide. So silicon dioxide, giant covalent. Sulfur trioxide is a simple molecule or simple molecular. Easy 2 marks. If you've done your revision, easy 2 marks. Explain why silicon dioxide has a higher melting point than sulfur trioxide. So this is going to be about the type of bonding in each structure, and silicon dioxide is giant covalent, so it's not going to have any intermolecular forces, whereas sulfur trioxide has got covalent bonds inside the molecule, but it's going to have intermolecular forces outside of the molecule. So you've got to be really careful with what you say here, so that you don't lose yourself any marks. So I've got 4 marks. So I would split this into 2, thinking, right, I need to say 2 things about silicon dioxide, 2 things about sulfur trioxide, and that should be enough to get my marks. So what am I going to say? So I'm going to start with silicon dioxide. I'm going to say it's got covalent bonds, giant, and it's got high melting point because it's got many strong bonds to overcome. Okay, so let's start off by saying silicon dioxide has many strong covalent bonds, and I'm going to compare it to next to sulfur trioxide. So sulfur trioxide, SO3, is a simple molecule, and it's going to have weak intermolecular forces. Its intermolecular forces is going to be van der Waals. It's not a polar molecule. So I'm going to say that. I'm going to compare the two. So sulfur trioxide has weak van der Waals forces between molecules. If I was in an exam and I wasn't sure what type of intermolecular forces the molecule had, I would say it's got weak intermolecular forces, and then I'm kind of okay there. It's not asking me specifically for which type of intermolecular forces it has got, so I won't get into any trouble with that. So if you're unsure, you can say that. If you are sure, then go with what you know. So I'm going to compare those two forces now. So covalent bonds are stronger, and it's that ER word that's really important there, than van der Waals forces. So take more energy to overcome. Okay, so let's just review what I've got here. So silicon dioxide has many strong covalent bonds. Sulfur trioxide has weak van der Waals forces between molecules. The covalent bonds are stronger than the van der Waals forces, so take more energy to overcome. So silicon dioxide has a higher melting point. And I'd get my 4 marks from that. Okay. So I can't remember doing this, but I've already got the answers written in here. So write an equation for the reaction of sulfur trioxide with potassium hydroxide. So I've got my sulfur trioxide there. I'm making potassium sulfate and water. So this is acidic gas plus base of potassium hydroxide makes a salt, potassium sulfate plus water, 1 mark. Okay, so you can work this out in an exam, and if you know it, great, it's worth 1 mark. If you don't know it, don't spend ages on it, come back to it at the end and just try and figure it out and take it back to basics really. Acid plus base makes salt plus water. Okay, so next question, write an equation for the reaction of excess magnesium oxide with phosphoric acid. So same thing really, I've got a base, I haven't got an acid, which is phosphoric acid. The formula for phosphoric acid tells me that the phosphate ion must have an overall -3 charge, and the formula for magnesium phosphate needs to mirror that really. So magnesium is going to be +2, the phosphate is -3, so I need 2 lots of them, gets me a total of -6, and 3 lots of magnesium gets me a total of +6. And I've got the same, I've got magnesium phosphate, which is my salt, and I've got water, three waters, and I've got my acid, and I've got my base. And again, 1 mark. Draw the displayed formula of the undissociated acid formed when sulfur dioxide reacts with water. So that's not that answer there. So sulfur dioxide reacting with water. So I am going to make H2O plus SO2. I'm going to make H2SO3 sulfurous acid. So I'm going to start off with sulfur in the middle. I've got 1 sulfur oxygen double bond, and then quite similar to the structure of H2SO4. So I've got these 2 bits on it here, but I don't have my 4th, I don't have that because I don't have H2SO4. I've just got H2SO3. So I might be able to draw, well, I would be able to draw a lone pair of electrons on there. Okay, don't know why that's not rubbing out properly, but you get the idea. Lone pair of electrons, 1 mark.